Hi everybody, how are you? Welcome again in this a new video which will be a quick one, I hope. It will be a quick one because most of the work have been already done. So what we are going to see on this video is how to read a microcontroller on a dead board, completely dead board. No rail comes up. It has even some missing component. Some in fact it's a donor board which I use, which I have as a donor board. I have even taken some ICs on this board, and even if we apply power to this board, we won't get no power at all. No 19 volt, no 3 volt, no 5 volt, and no 19 volt means not no power at all, which means that our microcontroller won't be powered, so we can't use adapter to read the microcontroller using the programmer. So what we are going to do is we are going to supply our microcontroller directly with 3.3 volt. Here is the 3.3 volt here, and here's the ground coming from my power supply, which is uh, set on 3.3 volt and 0.8 ohms. So what I have done is that I have supplied the microcontroller. I have connected the wires to the keyboard connector. Each, as you can see, I have numbered these wires here. We have here 60, 61, 59 here, and 62 here, and 42 here. These numbers are in fact the pins on the microcontroller. If we go, for example, let me show you. If we go to the RT programmer software, let me show you. So if we go to this software and we choose the KB here, we have chosen our KB9022 here because we are going to read a microcontroller model KB9022, and we are going to use an ISP method. So here, as you can see here, this photo illustrates how to connect wires to these wires. So here it shows how the adapter should be placed on our programmer. So the adapter should be here at the bottom here, and here's the wiring. So as you can see here, sorry, let me show you again. So here we have the wiring. So here we have the pin 60, 61, pin 62, pin 90, 59, sorry, and pin 42. So each pin has to go to the corresponding pin on the keyboard connector. So how to find the corresponding pins on the connector is simply either you check on the schematic. If no schematic available, as in this case, so you just have to use your multimeter, and with BPN mode you put one probe on, for example, the pin 60 of your microcontroller, and with the other probe you check which pin is related to that pin, to that 60 pin on the keyboard connector, and you made a list. You'll try to make a list like this one, in which I have each pin. Here we have 42 goes to pin 18 on the keyboard. So here we have super IO pins, and here we have keyboard connector pins. So 42 pin of super IO goes to 18, to pin 18 of the keyboard connector, and here 59 goes to 5, 60 goes to 6, 61 goes to 3, and 62 goes to 2. So you have to solder each wire to the corresponding pin on the keyboard, so that you can read your microcontroller. And don't forget to put to use or to ground, don't forget to ground. Here it's a crocodile clip which I solder, which has a wire, and that wire I solder it to this USB cable, which I am going to use with my programmer. So here the programmer is on, everything is on place. So we just for those who have never done this, pay attention to the wires soldered here. There shouldn't be no short between those wires, otherwise you may damage the microcontroller. Another thing, to check whether the wires are firmly connected or are well connected to the keyboard, you can check the voltage present here when powering the power supply, or when powering the microcontroller with 3.3 volts. So let's power our power supply. It's on 3.3 volt and 0.8 ohm. So let's push the on button. Here it is, and let's use the ground here and check here. Oh, sorry, I have to remove this and power off the power supply, power again, and make it on. So here we have 3 volt, 3 volt, 3 volt, 3 volt, 3 volt on this one. So all of them have the 3 volt. So if we connect the programmer, and let's use this ground here, we have nothing, 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 nothing. So what does it mean? That means that you shouldn't connect your programmer in the beginning. So let's take it out and let's go to our software here. So we remove this history here. So our power supply is on. Let's power it off. Why power it off? Because the microcontroller may be busy, because it's supplied by 3.3 volts. So let's power it and power the power supply off, power it on, and now we can, as far as I connect this, I have to quickly click on read on my software. So I got an error. Let's try again. Okay, don't worry. Power off the power supply, power it on again, connect, read. Error. Okay, check the ground. Pay attention not to touch the 3 volt with the ground. So again, read. Error. We will read it, I am sure, but we have to be patient. Let's power off the power supply, power on, and read. Successful. So we got the file. Let's put it on desktop. Let's just create another folder. Let's call it 9022 KB. Okay, that's fine. Open, save. And let's power off the power supply, power it again, and read. As you can see here, we got this error. So even if we try again, we won't get nothing. So let's select all, remove this history again, error. So what we need to remove the power of the programmer, power of the power supply. The microcontroller may be busy, then power on the power supply and connect this and go to read. We may get an error, but let's just put read again. Okay, power off the power supply, power it on again, and read. Again, successful reading. Where's the folder? Here it is. Let's check these files, analyze, data comparison, compare. Okay, so they are identical, as you can see here on this message. So we have done the comparison using the HXD editor, or any, or you can use any binary or any hex editor. So let's close these. So now let's try to write the microcontroller. So let's open which file. Let's write it with the same file, just as a test. Let's open it. Let's write. We will get an error, I'm sure of that, because we need to initialize the microcontroller by powering off the power supply and then power it again, then try to write. But sometimes it's just weird with this. Yes, the writing is successful. So let's read again. Yeah, okay, it's, so let's call it before or after writing, yes, save. Let's open one of the previous files and this last one, both with the hex editor, and let's analyze to see whether the writing was done successfully or not. Yes, the files are identical, so the read and write of this microcontroller is successful, even if the board is a donor board or a trash. So we came to the end of the video. I shall stop it here, and I'm going to write this microcontroller with the file with the file of the board which will hold, or the board on which I will use this microcontroller. I am going to write this one with the file of that board, so that I just have to take it off from here and put it on the other board, and that's it. I hope it's clear, and I hope that you like this video. If any question, as always, you can ask either on comments or in the ARS server. So see you in the next tutorial, and bye bye.